Yeah.
Okay, what I want to do first is plug this rack in. So, before we get going.
Hey, Cody, you can move my book.
Power it up. Okay. Ready to roll?
Yeah.
What we're going to do now is a complete configuration of a rack for Allen Bradley SLC500 series CPU. We've got a 10-slot rack right here, and we're going to configure this so the CPU knows which cards are plugged into which slots, which is important when you've got one of these multi-slot CPUs. You can switch cards around. That processor needs to know where things are at, so we're going to show you how to set that up. First step on my laptop, I'm going to go over here to RS Links. Before you can do anything with the PLC, you need to establish communications between the laptop and the PLC. That's done through the RS Links program. So coming over here to communications, I need to configure drivers. Right now I've got a driver running called DF1, and I want to make sure this is configured with the right parameters. So I'll go over here to configure, and I'll go auto configure and just make sure it's talking at the right speed. And it says it's successful, and do it again just to show you again. It's talking at a baud rate of 19,200 through COM port number 1 on my laptop, and talking to the PLC. So if we now close this out and go to communications again, RS Who, underneath the ABDF1 driver, we should see the PLC show up here with no red X. It showed up red at first, I had to refresh that, and now that it is talking to the PLC, and that shows us we've got good communications. Just to show you by contrast, I've got another driver set up for my PLC at home, and that one shows up with the red X, because that PLC is not currently connected. It's looking for it, and it doesn't see it, so it puts a red X through it. Here, on the PLC we've just connected to, it is talking to it, so everything is well. So, I'm going to close this out. You can close out RS Links, and you haven't really shut it down. It's always down here in the system tray. It's always running in the background. So next one I'm going to go to is Start menu here. I'm going to start up RS Logix 500 English. This is the program we use to actually modify parameters in the processor and configure I/O channels and write programs. So I'm going to go here, and to establish the proper driver, even though it looks like it's established right now, I want to show you how to do this. You go up to the Tools menu, you go to Options, then under here you go to System Communications. Now, truth be known, you can also do the same step from the Communications menu there. However, sometimes I've found that doesn't always work. This always works. Going under Tools, System Options, and then System Communications. Excuse me. We can look for a current driver to use. Right now it detects one active driver. We can also select who's active if we want to see that, and that'll bring up a view of the communications available, and then we can expand there and say, oh, I want that one right there. That PLC is what the driver I want to talk with. There we go. But anyway, we're set up here at this point, and we've got the correct driver, so I'm going to say OK. Next thing I'm going to do is go over here and try to go online with the processor and just see if we can go online. I'll create a brand new file. And so far, so good. We're in remote program mode. If I try to go to run mode, see what happens here. Notice I get a fault light. Take a look at that fault light right there. That fault light also shows up here on the RS Logix programming software. I can investigate the nature of the fault if I wish. I can go to error right here, and it says discrete I/O module in slot 1, which is required for the user program, is detected as having the wrong I/O count. This could also mean that a specialty card driver is incorrect. What's happened here is I've swapped the I/O cards from this rack since the last time it was working. So the configuration we have here is not what that PLC is expecting. And that's basically the gist of the error. I'm going to close this out and go offline. In order to correct the I/O slot configuration, I have to be offline. So I'm going to go offline. I won't save any changes. Okay, now I'm offline. I'll create a new file. Here's what I'm going to do. When I'm offline, I go over here to I/O configuration. I double click that. That brings up a window telling me the configuration that it has. And right now the configuration is wrong. Notice here it says that slots 2 and 3 are blank, slot 6 is blank, and slot 8 is blank. Well, slots 2 and 3 are not blank. They're actually being used. I only have one blank slot, and that's this one right here. 0, 1, 2, 3, 4, 5, and 6. Number 6 actually is a blank slot. All the others are filled. So what I have currently plugged in the rack is not what the processor expects. And like I said, that was the gist of the processor error that we just looked at. To correct this, I go to this button that says Read I/O Configuration. I'll go to Read and say, yes, I can read I/O configuration. And when I do that, notice it updates that list. Now we have a proper list. It's identified all the cards plugged into the different slots. And notice here the only unused slot is number 6, which is what we expected. So there I go. It's working just fine. So I'm going to close this out. Now what we've done here is technically part of the program. We need to download that to the CPU to get rid of the fault. So I'm going to go over here where it says offline and go to download. And I can give this file a name. Let's just call it test for now. Click save. Are you sure you want to proceed? Absolutely. It's writing that. Want to go online? Yes. Good. We're in remote program mode. I can switch to run mode here. Since my key switch is in the remote position, I can go to run here. Are you sure you want to go to run? Absolutely. And we are running. Notice we're running. We go over here, the run light should be on. There's no fault light either. So it means it's happy now with the rack configuration. It doesn't see any faults whatsoever. At this point, we're actually ready to start programming if we wish. Now before we do that, there's one more detail I want to show you, and that is the I/O files, data files. Since we have configured this, excuse me, we've configured the rack and so it knows which card's plugged in where, it has updated the available data files. So right now, notice how the first output file we have is output slot 3.0. Well, here we go. Slot 0, 1, 2, 3. And sure enough, that's an 8-bit or 8-channel output card. So when you look over here in slot 3, you only see 8 bits that are available. It knows the type of card that's in there, and it truncates the number of available bits accordingly. Notice also the next one is output 5.0, 5.1, 5.2. Let's look at card number 5. 0, 1, 2, 3, 4, and 5. And right here, this actually says input card. What this means is this particular input card has a set of registers you have to write information to in order to configure the different channels on the card. This happens to be an RTD or resistance analog card, and to configure this it has several different options. The way you do this is by setting bit states in these registers. It's called an output file because even though it's an input card, you're having to write information to those bits to tell that card how to behave. So that card actually does have a set of output registers you have to write to. If we continue to go down, notice it shows another card in slot 7. Let's see that one. 0, 1, 2, 3, 4, 5, 6, 7. That's an analog output card. We expect to see 4 channels there, 7.0, 7.1, 7.2, 7.3. And then, in slot number 9 right here, we have an 8-channel triac output card. So sure enough, we have a O register with 8 bits available. If we take a look at the input, we see the same thing there. The input data file. Input, we have a card in number 1 right here. Input card, slot number 1, 16 points, which is why we see 16 bits available to us. Slot 2, we see another 16 bits because in slot 2, another 16-channel input card. Slot number 4, we have several different words here. Slot 4.0, slot 4.1. Well, here's slot 0, 1, 2, 3, and 4. This is a 32-bit discrete input card. Because each word in Allen Bradley is 16 bits long, this takes 2 words. So here in the input file, we see I:4.0, I:4.1. Our first word, our first 16 bits are right here in I:4.0. The next 16 bits are here, I:4.1. And so what we see is a 32-bit input card shown as being in that one slot with 2 different words, 2 different 16-bit words. All right, and that's the basic rundown of this processor, the rack, and the I/O that we see associated with it. Now it's properly identified those cards.